Earlier in the notes, we talked about, and actually in section 3.1, we talked about how outliers affect correlation, the strength of the correlation. But now we're going to look at how outliers affect the actual regression line and its slope in particular. So let's just define again, an outlier is a point that doesn't fit the underlying pattern in the data or fits the underlying pattern but is far away from the rest of the data. An outlier may or may not be an influential point. I want to define a term called leverage. The farther that a point is from the mean of x, the more leverage it has. It's supposed to be it. Think of the regression line as a teeter-totter or a seesaw with the x mean as its fulcrum. Okay, so in other words, here's the line and here is the fulcrum. Okay, a point that is far to the left or the right, I didn't mean to erase, a point that is far to the left or the right, like sitting right here, will tilt the line, whereas a point that's right in the middle is not going to make much change in what happens to that line. Okay, now this point here has more power to tilt the regression line towards it than a point near the middle. So we're going to go to StatCrunch and look at an applet in StatCrunch to talk about this issue. So StatCrunch has some nice applets in it. This one is called Regression by Eye. And we have here some data. And if we were, and I'm actually going to do a different one because I want something that's a little bit more linear looking. And I'm going to put the regression line on here. Okay. Now I'm going to add a point that is far from the mean. So first of all, I want to point out that a high leverage point is far from the mean of x. So this line right here represents the mean of x. So I'm going to add a point that's way over here. And notice if I move this point up and down, how much it influences the line of best fit. It pulls the line of best fit towards it, and it changes the slope. If you look down in the little chart below, it changes the slope quite a bit. Now I'm going to add a point that is directly below the line, the x mean, okay? And I'm going to scoot that point up and down. Notice that it makes very little difference in the slope of the line, okay? Doesn't change it hardly at all. It changes the y-intercept slightly, but doesn't change the slope hardly at all. However, we know that it would affect the correlation quite a bit because this is going to increase the residual down here, so it would strengthen or weaken the correlation depending on where it is. So there's the advantage. That's an explanation of leverage. Now we're going to look at what an influential point is. A high leverage point can be an influential point, but not always. An influential point is defined this way, that if you remove an influential point from a set of data, that the slope of the linear model will change significantly. The point will not necessarily have a large residual because it tends to pull the regression lines towards it. An influential point must have high leverage and be inconsistent with the trend of the rest of the data. Note, a high leverage point that follows the trend of the rest of the data does strengthen the correlation, but is not always an influential point because removing it may not change the linear model very much. I am going to go ahead and go to an applet where I got these pictures from, and I'm going to attempt to duplicate these pictures as closely as possible. And then we're going to talk about what would happen if I remove the point marked A. What would happen to the correlation and the slope of the regression line if point A is removed. Here's the first example. What would happen if I remove this point? So note what the correlation is, look what the line's doing. If I remove this point, now we have a drastic change. So we can definitely say that that's an influential point. Putting that point changes the slope of the line from being positive with a high correlation to be negative with a fairly mediocre correlation. So let's go ahead and summarize what this does. As we saw when we removed point A, it changed the slope of the regression line from positive to negative. Therefore, we can say that point A is an influential point because it makes a drastic change in the correlation. As a matter of fact, the slope of the line kind of goes downward, probably not quite like that, kind of goes downward now instead of upward. Also, the correlation becomes weaker. Okay, now that doesn't make it an influential point because it changes the correlation. It makes it an influential point because it changes the slope of the regression line significantly. Okay, let's look at the next one. If the graphs that I'm showing you right now don't look exactly like the one on the paper, it's because I'm trying to duplicate what I drew another time as best as I can. So notice here's the equation of the line. Oh, and I forgot. Hang on, I got to put one more point. There you go, that's better. And it might even look a little bit more like the one I have not in the paper now, except that that line was below. But anyway, it's pretty close. The point here that I'm checking out is this point. What would happen if I remove this point? So think about, here's the correlation coefficient. Will it strengthen, get closer to 1, or weaken, get farther away from 1 if I remove this point? Also, what will happen to the equation of the line? Will the slope change drastically? So let's just try. Okay. There's a slight change in the slope, but not very drastic, just a little bit. Notice, though, there is a fairly drastic change in correlation. Notice how much stronger it is when we remove that point, because that was the point with the largest residual. So if we summarize this, we can say that it is not an influential point because it doesn't change the slope of the line much, but it does affect the correlation. So I'll write that. Removing point A does not change the line very much, so it is not an influential point. However, removing A does strengthen the correlation. Remember, that does not make it influential. It only is influential if it changes the slope of the line significantly. Okay, third example and last example. Okay, we notice here that we do have an outlier. It is far from the mean of x, whereas before, in the middle example, A was close to the mean of x, which is why it didn't have very much influence when we removed it. But this is far from the mean of x, so how much influence is it going to have on the line of best fit? Notice here's the correlation. If I remove this, notice the correlation is weakened, but the line does not move at all. That's because this point is already in line with the rest of the data, so it is not an influential point, even though it is far away, even though it has high leverage. It doesn't change anything because it's already in line with the rest of the data. So let's go ahead and summarize that on our notes. I do want to add one more point, that notice this is above, or at least approximately above x bar. That's why it has little leverage. Okay, it has little leverage, and so that's why it doesn't have much of an influence on how the line moves. Here, if we remove point A, the line doesn't change much. Actually, hardly at all. The line doesn't change. Therefore, point A is not an influential point. Removing it, however, does weaken the correlation. Removing A weakens the correlation. Okay, so we have three situations here. This point is an influential point because it has high leverage. It's far away from the mean of the data, and it is not in line with, it doesn't follow the trend of the rest of the data, so it's extremely influential. This is probably a very exaggerated situation, actually. Removing it changes things drastically for the line of best fit, so it is influential. It also happens to change the correlation, making it weaker. Both of these do not change the line much, so neither of these is an influential point. This one's not influential because it is above the x bar, so even though it's not not consistent with the rest of the data, it doesn't make a lot of change in the regression line, even though it does strengthen the correlation a lot to remove that point. This point does have high leverage, but it's in line with the rest of the data, so it's not influential. It does not change the line much, but it does weaken the correlation then when we remove it. I just got a phone call, and I've been away from this recording for about 15 minutes, so I have absolutely no idea what the last thing I said was, but I believe I'm done. So this is the end of the 3.2 notes.